first one is the domain of a log. Now remember, I can ask you for inverses as well, right? But you would just find the domain and range of whatever the heck the original one is. Switch x's and y's, like don't overthink it. So a log function, we just have to remember that log functions, basic log function has an asymptote along the y-axis, and then it either increases or it decreases. That's a basic log. What can move the asymptote?
Horizontal translation.
Yeah, taking it and pulling it this way or this way, correct? So horizontal translation can move your asymptote. What can cause your range to flip? Or the domain, I mean. Your domain to flip. If it's faced like that, how can I get this to be over here? Reflection in the y. So I have to have a negative x in order for my range to flip, correct? So if I look here, do I have a negative x? No. So what is the domain of my function? X is greater than negative 4 xer. And it's because, why? Because you have a vertical asymptote at x equals negative 4 and you don't have a reflection, right? So it can't actually equal it. This one here is a log again, and what I'm going to do is always get it into y equals, so I'm going to move my 6 over. I'm going to get log, I'm going to take a 2 out, I'm going to get x minus 5 halves, then I'm going to add 6. Now what do I care about when it talks about the asymptote of a log? Yes? Yeah. Because your asymptote of your log is a vertical asymptote, and it's at x equals your horizontal translation every single time. That's for a log, correct? Your vertical asymptote is x equals your horizontal translation because it's normally at x equals 0. Now it's going to be at wherever the heck we move it. It's at 0. We're moving 5 over 2 to the... Moving 5 over 2 to the right. So it has a vertical asymptote at x equals 5 over 2. The next one's an exponential. Exponential functions look like this. Your basic ones without any transformations have a horizontal asymptote at y equals 0. What's the only thing that can move that bad boy? Vertical translations. And normally it's either increasing or decreasing above. What can cause it to be down here? A reflection in the x-axis. So a negative with my y, correct? So the only thing that can move this, so for every exponential function, I have a horizontal asymptote at y equals the vertical translation. So what is my vertical translation on this one? It's d down, right? But when we write it as an equation, we're going to write it as y equals negative d. That would be my horizontal asymptote. Now, does this reflect down? Is there a reflection in the x-axis on this one? No, there would have to be a negative in front of here. Not in the 3, but actually in front of it. Correct? Is there a negative there? No. So is it reflected down? No. So it's still what? Greater. So your y is greater than negative d. If you want to write the whole thing out properly. Or in integral notation, it would be negative d to infinity. Now this one, you have to be able to spot these. They will give you a piece of information about a log, and then they'll just give you like a statement. And you have to do something with that statement that will make it look like the information they gave you so you can actually do something with it. Okay? So this is information given. I'm just going to let it sit there for a little bit. I'm not even going to think about it. I could think about that if I can get log base 6 of y, somehow I can replace it with a t. Correct? But this is the actual information they gave me. They gave me log base 6. And then I have two things multiplied, so I make a point of showing that. I put a dot in there to prove that there's actually a multiplication. When I have a multiplication, what can I do? Split them up by addition. So I can get log base 6 of 36 plus, anything beside log put in brackets, log base 6 of y. What is log base 6 of 36? 6 to what exponent is 36?
2.
2. Plus, what's log base 6 of what? T. So it's d. Now I want to change the question up a little bit. Now instead of giving you 36y, I want you to do this exact same question, But I want you to do it with log base 6 of 36y cubed. Try it out. Same information, log base 6 of y equals t. But I want you to figure it out with that.
No spoilers. So do that.
Invented spoiler? Okay. This is the same as saying 36 times y cubed. Do we agree? So we could expand it as log base 6 of 36 plus log base 6 of y cubed. Now the error lies here in the fact that people want to take log base 6 of y, which is t, and then cube it, which I can't do. I can only replace log base 6y. I have log base 6y cubed. What can I do to get log base 6y? Yeah?
You could drop the 3 in front of the log.
Yeah, drop the 3 in front of the log. If you're someone who wrote t cubed, you should be starting this, because you're probably going to do it again on the test, which is a problem. So 6 to the what is 36? 2. That didn't change. But now I have 3 log base 6 of y. And what's log base 6 of y the same as? T. So I get 2 plus 3t. Do you see how that can happen? See how you have to bring the exponent down in front before you can replace? Not right, t cubed. It would be wrong. Number 5, even though it has logs embedded in it, it is a common base question. So whenever you have a base with an exponent, always check first to see if you can do common base. This one we could actually convert to a log, but good luck. It would be real ugly. It would be like log base 3 of 1 over 81 equals log base 2a. So I'm going to make them both be base 3. So it's going to be 3 log base 2. Now these are both base 2, and they have 1s in front, which is my stipulation, right? When they're base 2, it should scream, put me together. And when they have 1s in front, you can put them together. But if they don't have 1s in front, you have to move them up as the exponent. Correct? So I can put these ones together because they have 1s in front, and they're both base 2. So I get a and 6. So I get 6a, or a times 6. It's the same thing. That's on the left. And then 81, not 1 over 81. 81 is 3 to the what? 81 is 3 to the what? 3 to the 4. So 1 over 81 is actually 3 to the negative 4. So you can look at it as if it's just a number and then raise it to a negative exponent. So 81 is 3 to the 4. So 1 over 81 is 3 to the negative 4. Now I can actually set the exponents equal because I have one base and an exponent, one base and an exponent. So I get log base 2 of 6a equals negative 4. 2 to the negative 4 equals 6a. Divide by 6. A equals sum. 1 over 96, I believe. 1 over 96. Now this one is like the ELSA one that I told you to star with ELSA stars. It's the same thing, different pile. So if we have log base b of p, and we have log base p of q, and we have log base b of 4, and we have log base b of 5s, if we can change all that other expression into any of those, I can replace. Right? That's all it's saying. So I don't touch any of these. I just know that if I have a p, a q, a 4, and a 5, I can change them into numbers. So I wanted to change this one. Log base b. Now I have 4s and 5s somewhere over here. 4s and 5s. And I need to get 320 into 4s and 5s. What does 320 break into with 4s and 5s? 4 times 4 times 4 times 5. And then I have p and q cubed. Right? Now when they're all multiplied, I can just separate them by what? Addition. If you spot this, these are really, really easy questions. If you don't spot it, you stare at it for a very long time. It gets real sad. Okay. So we get log b of 4 plus log b of 4 plus log b of 4 plus 5, plus log b of 5. Excessive, but you can get it right, so I don't really care that I'm writing out this much. Log b of p plus log b of q cubed. Now this is one where you're going to have to watch yourself again. Log b of q cubed. Do I have a q cubed? Do I have a log b of q cubed? No, I have a log b of q. So what am I going to have to do first before I can fill it in? Drop the 3 in front. I'm way too lazy to rewrite that. So I'm doing that. Okay, log base b of 4 is equal to a plus a plus a plus log base b of 5 is c plus p is 4 plus 3 times q is 2. Yes, it'll result in 6, but I'm not really going to do that. So I have an a plus an a plus an a. So how many a's do I have? 3 a's. I promise you, if you think of adding subtracting variables, think of it as objects. Like 1 apple plus an apple plus an apple. Now I have 3 apples. You won't make a mistake. I know it sounds silly, but you won't try and give me like apples cubed. You won't. Plus c plus 10. Done. For 7, I'm missing a variable in the base of a log. If I'm missing a variable in the base or a variable beside the log, I'm going to have to do what when there's a single log? Convert to exponential every single time. If the variable's in the base, I'm going to have to have an exponent, which makes it a little harder. If the variable's beside the log, it's a little easier. So I'm going to get a, the base of my log is the base of my exponent. If I had something in front of this log, remember it would have to come up as the exponent first, correct? So it's going to be a to the negative 1/4 equals 1/16. How do I get rid of negative 1/4? Times by negative 4/1. Because we need to times it by something that will turn this into a 1. Correct? Negative 4/1. Because a negative 1/4 times negative 4/1 is a positive 1. It's a really big 1 there. And then a equals what? 2? Because technically this would become 16 to the 4 to the 1/4 if I wanted to flip it.
I did it a different way.
Did you take the 1/4 root? What did you?
Well, I did a to the negative 4 equals 16, and then screwed it by.
A to the negative 4.
Yeah.
You went a to the negative 4 equals 16.
Yeah, and then I did just like, I know it's like wrong, but like could be.
You just lucked out.
Yeah.
Because you'd end up changing that one to, yeah. It's going to be really big. It shouldn't be 2. It should be a really large number. Yeah, it should be because this is just 16 to the 4. This is wrong. Because if I wanted to do this actually, I could flip these and make this to the 4, right? So it'd be 16 to the 4. So it should be a big number.
Yeah.
I'm like looking at it, I'm like, this should be big and not small. You treated it as 1 over 16 to the negative 1/4. That's why.
Yeah.
Yeah. Or you have to show what? Not that I've seen. They could. Okay. This one. What's the problem? What am I testing here? If you remember to move the 2 over 3. That's what I'm testing. That's all I'm testing here. Do you know how to move the 2 over 3 before you convert? So this is what I'm going to say to you. If you go to convert it and then you have a random number sitting somewhere and you're like, oh crap, I don't know what to do now, don't convert it. Do something first. Like if you're like, the base is n to 5 equals x, and oh no, I have this. I'll just add it somewhere. Don't do that. It's a bad decision. Say, I can't convert just yet. I need to do something. This 2/3 is a problem. Can I move it somewhere so that it's not a problem? Oh, I can raise it to the exponent. Now it's not a problem. N to the 5, base my exponent to exponent, equals x to the 2/3, right? And it wants to know what x squared is. So what do I have to do? How do I get rid of a 2/3 as an exponent? Times it by 3/2. It's reciprocal. Because 2/3 times 3/2 is 6 over 6. You just multiply by its reciprocal. And then this becomes 15 over 2. The catch is I want what? Not x. I wanted x squared, which makes it turn nice. And to the 15. Number 9. I have more than one log. What's up?
I was just going to say, I did it different on that question. I just times 3 on both sides, because then it changed it to x squared.
And then it worked?
It worked. I got
Yeah.
same answers.
Well, I did log.
I just divided just by the other side, and I got the same answer. Like, would that work every time?
Wait 1 second. You moved it over with the 5? Yes, totally. Yep. I see what you're saying. Yep. And then you would have raised it to the 15 over 2. Yeah.
Yeah, I did.
And it only works because it's just a 5. If you guys had something else, like something with an exponent, you wouldn't be able to do that.
Yeah.
But because it's just a number, you absolutely can do that. Yep. It's totally correct. Number 9, instead of raising it as an exponent.
Oh, yes.
I'm confused as what you did. You explained to her, that's what I did. She said she was confused, and then you explained how you did it, and then she said, yeah, that's how I did it.
I was confused about the last one.
Okay,
That's the issue.
number 9, we have more than one log. Okay? We have to be able to spot and do. We agree? Spot and know what to do. So when we have more than one log and a number, we move the logs to one side and the number to the other. Now in this case I was nice. I put the logs on one side and the number on the other, but did I have to do that? No. I could have started this off as log base x of 2x plus 3, 2 minus log base x of x minus 2. And you would have to know to put them together. Remember, when any logs have the same base, they scream put me together. So you need to move them together to put them together. We agree? Now, they both have base x, so I can put them together, and the only other thing I have to check before I can put them together is, do they have 1s in front, which both of these do. So I can go log base x, and then these just end up getting multiplied. 2x plus 3 times x minus 2 equals 2, and then I always expand it before I convert. So I'm going to get 2x squared minus 4 plus 3 is minus x minus 6 equals 2. Now I have a single log, so I can convert. X squared, there we go, x squared equals 2x squared minus x minus 6. I haven't, this is grade 11. I need to move it all to one side. And I get x squared minus x minus 6. Now, this is great because it all was positive. Could they give me the entire opposite of this?
Sure.
These were all positive. Sure, I could. These were all positive, so I knew to make it positive. Plus, I was trying to make my x squared positive. But did I have to make my x squared positive? No. Could they have had the answer where you move everything else to this side, which would make it negative x squared plus x plus 6? Yes. Now, some people say, what if they have both? They can't. It's just, they're both right. They can't do that. Right? It just was easier because it was positive. Number 10 says determine the range of the inverse. So determining the range of the inverse, I don't give a crap that it says inverse. I kind of do. I kind of know. What does it tell me that I need to find in order to give the range of the inverse? Yeah. The domain of the original. And then just put y's in. Correct? So I actually don't care what the inverse looks like. So what I'm going to do is I'm going to remember what a log looks like. Because sometimes just drawing the log beside might help you. A basic log. So I'm going to do this every single time I'm asked domain, range, or asymptotes. So basic log has an asymptote. I'm going to sneeze.
Go back to the other question, 'cause I'm confused.
I'm Crystal. You're confused? Nice to meet you. I'll be here all day. What are you confused about?
Why do you switch? You switch the. Okay, never mind.
Good talk.
I just need to see it more.
Good talk. Okay. It's a log. When it's a log, I didn't even do that. Okay. When it's a log, if it moves again, I'm going to cry. When it's a log, it has a vertical asymptote on the y-axis, which is x equals 0. Correct? If it's a basic log, our basic logs are also to the right, like this, either decreasing or increasing. We agree with this, correct? That's a basic log. I always draw my basic log beside if I'm going to try and help myself out. So my basic log has a domain of x is greater than 0. We agree? That's a basic log. Before I go and do anything, what's the only thing that can move my asymptote when it's like a vertical one? Horizontal translation. So I'm really going to look for the horizontal translation. And then the domain, how am I going to make it less? If it's drawn like this, how am I going to make it less? Reflected in the y, so there has to be a negative on the x in the equation, right? If you do a little sketch beside, I promise you life is a little bit easier. Because then it's a little bit easier to visualize how you'd move this baby. Okay, so I want to get it, I actually don't, I'm going to get it into y equals, but do I need to get it into y equals? No, this nor this is going to affect it. I'm just going to practice. Okay, so I'm going to go 3f of x equals log base 2. When I take a negative a half out, this becomes a x plus. When I divide by negative a half, this number gets bigger. Correct? Right, because I'm GCFing out a half. When I divide by a half, I'm actually multiplying by negative 2, so it becomes a 12. Now, I'm going to add my 2 to the back. I didn't need to do any of this, but I'm proving a point. And then I divide by 3, divide by 3, divide by 3. And instead of dividing by 3, I write the third in front. Correct? We talked about this the other day. So we're going to write f of x equals 1/3 log base 2 of negative 1/2 x plus 12 plus 2/3. Now I didn't actually have to get this into y equals, because on a log, the only thing that affects your asymptote or your domain is this baby right here, just the x's. The x's can shift it, and the x's can reflect it. So the y's, that's lovely that it's 1/3 and 2/3, but they do nothing. They can be smiley face and a sad face. It doesn't matter. Okay? Because it doesn't affect it. I literally could put in a picture of a pig and a cow. It wouldn't matter. Right? Because these I can just ignore. It would make you guys go completely mental and you'd be really mad at me. But if I put a picture of a pig and a cow here, it would not change this equation at all. It would not change, it would change the equation. It would not change this question at all. Because my domain is based off of this. My domain is going to be x such that x is, it's a reflection in the y. So instead of it being greater, it's now going to be less than. Can't be equal to because it's an asymptote, correct? What's my asymptote now? It was normally at 0. It's been moved 12 to the left. So it's going to be less than negative 12 xer, which is lovely. But I want the range of the inverse. So I just take that and make y's. Yeah? We agree?
Yes.
Yes. Number 11. The moment I have bases, I will always check for common base. So this is very much like the other one. So we get 5 log. They're log base 3s. They have 1s in front. That's exciting. So I get log base 3 of x over 2 equals 5 to the 3. Then when I have the same base, I can actually set the exponents equal. So I get log base 3 of x over 2 equals 3. Convert to exponential. Base my log becomes base my exponential to the 3 equals x over 2. And then how do I get rid of a division of 2? Multiply. So it's 27 times 2, which is 54. Whenever it's a solve on the test, can you y1, y2 them? Every single solve. Solve logs. Solve exponential. Solve any of them. You should at least, the very least, know you got it right or wrong. Or it's a multiple choice, you just type it in. Right? When you have, yeah, okay. When you have a log embedded in a log, you're going to have to convert to exponential that many times. So I have one log embedded in a log, correct? So I'm going to have to convert to exponential twice. We're going to do this one, and then I'm going to give you another one. I'm going to randomly make it out of my head, so it could be crazy bad. That's okay. All right. So we can only convert to, I mean crazy bad is in large numbers, not crazy bad is in a bad question. Okay. So I can convert to a log if there is a 1 in front, which there currently is. Do you agree?
No.
Log on left, number on right. Now this is the thing. You work from outside in. So I'm going to go 2 to the power of 1 equals that. Because that's the inside of my log, right? 2 to the power of 1 equals that. To prove a point, that's 2. And now I'm going to have to do what again? Convert again. So 2 logs embedded, convert twice. 3 logs embedded, convert 3 times. That's what you're going to have to do. So it's x to the 2 equals x plus 12. X squared minus x minus 12 equals 0. And then I get x minus 4, x plus 3. And whenever I solve logs, I always have to check for what? If they work. Or if they're extraneous. So I take the 4 and I plug it back in. 4 on the base is fine. 16 here is fine. That will give me the right answer. Yay. Take a negative 3. Negative 3 in my base. Am I allowed to have a negative here or a negative here? Nada. So I circle it. I put a line all the way through it. And I say extraneous. Now, if you spell extraneous wrong, but they can sound it out, you'll be okay. If you spell like extraterrestrial, you're not getting any marks. Okay? It has to be the word extraneous that we can at least sound through. Yeah.
I somehow got like the opposite signs, like x plus 4 and x minus.
Yeah, that is because we messed up over here.
I don't know what you did.
Like I did x plus, I didn't put it on one.
What do you have here?
That.
So you actually should have a negative in front here.
Yeah, and then negative in front of that x plus three.
Yeah, and then it,
Oh,
Then
when
you
you
gotta
bring that
carry it
negative,
through.
you
It goes
bring the
through.
negative over to the goal.
No idea what they're saying.
Don't worry, I'm helping.
But I,
She still seems very confused, so I don't think your helping is working.
Yeah, and then I got negative x squared plus x plus 12, so it would be like,
You have to do decomp.
yeah.
You have to do decomp. The moment you have a negative x squared, you can't go to brackets.
You're just about to.
That's your problem. Negative x squared plus x, or, plus x plus 12, you said? Then you have to go negative x squared plus 4x minus 3x plus 12. The moment you have a negative x, oops, negative x minus 4, minus 3, x minus 4, you'll get the same answer as me. You didn't do decomp. You'll get negative x minus 3 and x minus 4. When you solve negative x minus 3,
Oh, okay.
I would never do this if I were you.
Yeah.
I would move it to the other side after. Because you can always shift everything from one side to the other. You have to decomp if there's a number in front. You're forced. There's no way you can get around it. But if you have a negative x squared, you can just move all of them to the other side and never decomp.
okay.
So if I have these, I'm like, yeah, no thank you. And I move them to this side and just do products.
Okay.
If you have a number, you're forced to decomp.
Yeah.
It's just when it's a negative one you can move it. The whole thing though, everything's first. Okay, here's one to try. Good luck, because I don't know how it's going to turn out. Log 2, log base 3, log base 2 X plus 1 equals 1. Can't promise it's going to be pretty, but it'll work. How many logs are embedded? 3.
So you gotta
Yeah.
convert to
Four
exponential
times.
thrice.
3.
Where'd
you say more?
Did you just say that? Attack me for saying thrice. What about it? I don't think my English.
Alright, McLean.
Yeah, my English mark didn't say that, but.
Alright, where do I start again?
It won't be too bad. It's 2 to the 8, 2 to the 2 6.
What's 2 to the 8?
Wait,
I got 2 to the 9. Huh?
Oh.
I didn't get
2 to the 9.
boy.
Where's the 9 come from?
The 1 subtracts off. Kylie, did you bring it to the exponent?
Oh, joke.
Oh,
I don't know
just-
multiplication.
No, because you still have a log in there. You still have to write one more
Okay.
time.
Yeah,
Three
and
times
also then you get 2.
Not 3 squared.
Yeah.
Yeah.
No.
Basic multiplication.
No.
Oh, did I dyslexic it? I did. Ah,
It's not still.
Wait, what?
I dyslexic
I was-
for a second there. It's
I
fine.
erased all my work.
Don't do that. Jeez.
What's 2 to the 9?
3 squared, which is 9. And then it's 2 to the 9. There it is.
Good. And we're probably right. 'Cause we should be.
You should be at this point. There's not much left. There's literally a moving of 1.
Nah,
I don't know if we're right.
511.
I'm straight tripping.
I can't. I got 500.
Now,
Yeah.
I would have never walked away with that question being wrong. Why would I have never walked away with that question being wrong? Because I would have, why wouldn't my 2, which would have been kind of hard because it's 500, so I'd have to make sure my x max is really large, right? But I would have just plugged it back in algebraically and it wouldn't have equaled 1. And then I would have been like, oops, what did I do wrong? And then guess what I would do? Crystal in high school would have just tried to figure out the mistake and would have never found it. Crystal, old now, would not look at anything she did. She would grab a separate sheet of paper and start over. Because I may never catch the 3 squared, my silly mistake, if I try and just look for it. Or if I do, it'll take me 10 minutes because I'm trying to decipher through. What I do now is I'll just put a whole new piece of paper over it and try it again because the chance of me making that silly mistake won't happen twice because that's just an oopsie, right? That's not a lack of knowledge. I know it's 3 squared. I just flipped them in my head. So you won't often make the mistake twice. You did it? But if you throw a piece of paper over it, I promise you, you probably won't catch, if you catch, you might catch the error eventually, but it'll take way longer than if you just redo the question. But stupid Crystal, I would have just tried to find it because I'm lazy and wouldn't want to rewrite. You would have to type it in as log base 2, log base 3, log. You'd start from inside out, almost. Ish. Yeah.
I have to go because my parents didn't call, so I go call my parents and call
Yep.
school. So
Sure. You guys can figure that out.
I can't.
Nanya. Nanya. Okay. What happens when I have 2 bases, 2 exponents, and I can't make common base? What must I do? Log base 10 both sides. Now remember, what can I do? Shh. I can add like a 2 in front of here, right? And then, you guys paying attention? I could add a 2 in front of this 5. I don't think you guys are paying attention. I swear. This is me helping you, not you helping me. Okay. If I put a 2 in front of here, it's 2 times 5. And if you're saying, where did I get that? I just made it up. This is not real to this question. But say I did this, because I can do that. I can actually just add an extra number. Remember, I'm still going to log base 10 both sides, but I'm going to have to separate this by an addition. I'm going to have to go log base 10 of 2 plus log base 10 of 5. Because if I throw a log base 10 in front of this, those are two multiplications, correct? And how do I separate them? Addition. So there is that extra addition step you have to do if I throw an extra number in there, which could probably happen.
I thought it just came out of nowhere.
No.
I'm really confused.
So this has absolutely nothing to do with this. I just wanted to prove that if I have a number there, which I can do, which I probably will, you have to be able to do it. So log base 10 of 3 to the 3x plus 2. So we're going to get 4x minus 2, log base 10 of 5 equals 3x plus 2, log base 10 of 3. And then I distribute. So I get 4x log base 10 of 5 minus 2 log base 10 of 5 equals 3x log base 10 of 3 plus 2 log base 10 of 3. X is on left, numbers on right. You could put x's on right, numbers on left. It doesn't matter. I just like consistency. So 4x log base 10 of 5. And I want to show you something because of... Can you just add minus 3x log base 10 of 3 equals 2 log base 10 of 3 plus 2 log base 10 of 5. And then I divide them out. And I get, or I take an x out. Heck, damn it. That's an extra step, sure. 4 log, ignore that line. I'm just not getting this. Equals 2 log base 10 of 3 plus 2 log base 10 of 5 divided by 4 log base 10 of 5 minus 3 log base 10 of 3. What do you get as an answer?
1.72.
We could have y1, y2 to the step before that one, right?
Yeah.
Why would you? You would y1, y2, the original, which is substantially easier.
Oh, yeah, definitely. Well,
So if it's algebraically, you have to get to that. And you guys, just so you know, when you're solving, are you paying attention? When you're solving, if you make a mistake along the way, that is a good point. If you make a mistake along the way when you're solving and you don't know where you made an error, you could y1, y2 the first step, or the original equation, get an answer. Then you could y1, y2 the first step. If it's the same answer, no error. y1, y2 the second step. If there's no error, no same answer, no error. And so when there's solving questions where it's like the student made an error, right? Could you not just plug in the original, get an answer, plug in their first step, see if it's the same, plug in second, third, fourth, fifth? Yeah, you absolutely can. The student erroring solving ones are my favorite because they're so easy. You just type them in. Well, you try and do them right, but, you know, reassuringly type. Okay? This one here, we have log base 5 of 625. 5 to what power is 625?
Help me.
4. Plus 3 times 2. Plus, and then 2 to the 16 to the negative 1. Is it negative 4? Negative 4?
Yep.
And then what's log base b of b? 1. Now say your brain fell out of your head and you don't know what it is. When we're given variables, what I'm trying to drill into your heads before the diploma is you can plug in things for them. Okay? So you're like, oh goodness, I don't know what that is. Even though log base b of b is 1. You could go log base 8 of 8. And it'll give you 1. And then you can be like, oh, it must be 1. No, you don't do that. That's one example. You have to do a few to make sure the pattern works, right? So then you could go log base 7 of 7, and it gets you 1. And log base 5 of 5, and it gets you 1. And then you're like, I'm a genius, it's 1, right? Same thing with this one, if you're stuck. Well, what you can do is, the way I do it is I go a to what power is 1? 0. So whenever beside the log is a 1, it is a 0 every single time. But say you forget. What could you do? You could go log base 7 of 1, 0. Log base 6 of 1, 0. Log base 5 of 1, 0. Log base 10 of 1, 0. All of them will give you 0. You can plug in values for the variables for your stuff. Okay? And so we get 7. The big kahuna. We're going to do this one at the beginning of class tomorrow because I have to teach something new today. In less than 5 minutes, always, and then, yeah. Okay, we're going to do that 15 tomorrow at the beginning of class. Really quick. So we're going back to perms and coms. Maybe. Okay. Yes. Yes. I believe you can go at the same time. I believe in the both of you. I think you can do it. Yeah, I'm going to the same ones. I hope. Just kidding. That's good. There are some that you could go to the same now, technically. The downstairs ones. That's okay. I was committed at that point. Might as well finish the sentence. It sounds really bad if I don't.
I hope you go to your girlfriend.
Okay. So here it has, Eric has been assigned the task of determining how many odd 4-digit numbers there are. I'm going to have a little sit down. So I know that you know this, and I know that there's no way you could have a gap in this, because my daughter in grade 4 knew this. So I believe in you. What is a 4-digit number?
Any number that can't start with 0.
Can't start with it. That takes me so long to get that, and you just answered that. You just saved time. It can't start with a 0, because if it starts with a 0, it would be a...
It says it in the first question.
I know, but you read ahead. Well, I thought that would be Max. Max is just checking out his hair, though, so he doesn't know. All right. Yeah, went there. Okay, so it's a 4-digit number means you have 4 blanks. Good reading. No one ever does. It takes me like 5 minutes to get
I just read it
So-
last class.
He was reading ahead. The last class to do this. Wow. Good job, Canyon. The rest of you have caught up now with Canyon. Okay, 4 digits, 4 blanks. Remember how we were doing blanks yesterday? Each blank contained one thing. We would have 4 blanks. Okay, let's do that. 1, 2, 3, 4. Good job. I'm going to sit back down. Now, it says a 4-digit odd number. Oh, what?
End in an odd number.
It has to end in an odd number, as opposed to everyone telling me it's not divisible by 2, which is also true, but not helpful in this instance. So a number that is an odd number ends in an odd number. If you don't believe me, you tell me if this number is even or odd. Ready? Paying attention? Even or odd? Ready?
No.
70,964,973,502.
Even.
Because you only listened for the last digit. That's it. Proving it to you. The last digit has to be odd. That's it. Right? People are reading ahead. All right. Anyways. So, it says here, how many odd 4-digit numbers are there? How many odd 4-digit numbers are there? Now, shh. It doesn't say that the numbers can't repeat, does it? Now, it will never say the numbers can repeat. The way you'll know that the numbers can repeat is it won't say they can't. That's literally how you narrow it down. So if the numbers can't repeat, it will say the numbers cannot repeat. Okay? What does that mean? That means the number 5, 5, 6, 7 couldn't exist because there'd be 2 5s. Okay? This one doesn't say that though. So I could technically have 5, 5, 5, 5, and it would be an odd 4-digit number. We agree? Now, we also said yesterday that we have to start off with the restrictions, correct? We always have to start with restrictions. So, I have to start with the back number. It can be 1, 3, 5, 7, or 9. I always list below the options. Remember, the options are listed below. The number of options are listed above. But how many digits are staying there? 1, just like there was 1 car. Now, we don't really care what digit actually stays there because there's nothing but repetition here. If we said we couldn't repeat, we'd actually have to keep a number there, right? And then say we couldn't use it in the next one. But that's not how this one goes. So how many options are there? There's 5. Okay? Well, then we have to go to the first blank, because that also is a restriction, right? Canyon, you said it can't be a? 0. So it can be 1 to 9. Now some people will say, well, why do we stop at 9? Because these blanks can fit one-digit numbers. 10 is actually 2 one-digit numbers, so we have to stop at 9. It's the last one-digit number. It can't be 0, because if it was 0, if I wanted to pay you in 4-digit numbers and I said, okay, I'm going to pay you 0038, you'd be like, no, that's 2 digits. That's not enough. Okay? So we have 1 to 9, which is how many? 9. And then in the middle, was there any restrictions on those middle blanks? No. So what numbers do I have for them? 0 to 9. And then dumb Crystal in high school was like, you just told me we can't have 2-digit numbers, and you're going to put 10 and 10 up here. But I was stupid, because I said you can't have 10-digit numbers as an option, correct? So what am I doing on the bottom? I'm listing the actual options I can have underneath. But what am I putting on top? The amount, which isn't an actual, like 10, that's not a number I'm using, right? That's just an amount. So do I need the first and second and third and fourth digit to get this 4-digit number? Do I need all of the digits? Or could I have 1 or 2 or 3 or 4? You need all of them, so I need to and. So what am I going to do with them? Multiply. So I'm going to get 4,500. Now there's this one. Eric has now been assigned the task of determining how many odd 4-digit numbers there are, but the catch here is no repeating digits. Now when I used to teach this, it used to be really, really awful because I didn't come up with the method that I have now, which is not nearly as awful. So if you follow this method, it's really, really easy to do these questions. Okay? We still start off the exact same. We can, in order to have a 4-digit number, we have to have 4 blanks. In order to have an odd 4-digit number, we have to end in 1, 3, 5, 7, or 9. We agree? Which is 5 options. The catch is that whatever number is in that blank, I can no longer use. We agree? So there's going to be 1 less option. So what I do myself is I box one of them. Now, you can box any of the 5. It doesn't matter which one you box. It just can't be rewritten in the next blank, right? So I'm lazy, so I box 1 or 9 every single time, because then I can use little arrows. So I'm going to box a 9. Okay? If I box 9, could you have boxed 1, 3, 5, 7? Yes. Just in the blank, in the first blank, then you wouldn't list that number. Okay? I boxed the 9, so now instead of, I still can't have 0 here, because I never could, but instead of having 1 to 9, I actually have 1 to 8, which is 8 options. Now watch yourself. This is where the error happens, is in the second blank. I'm going to actually start this one, because this one gets done poorly. So, I'm going to box the 8. So then people say, okay, well I have 1 to 7, and they write 7 options. There's actually, yeah, there's 8 options, because what comes back? The 0. The 0 couldn't be used in the last blank, because I had to have odd numbers. The 0 couldn't be used in the first blank, because I couldn't, or it would be a 3-digit number. So you can't forget to bring the 0 back. Whenever it's the non-repeating ones with these, it's 8, then 8, because the 0 actually comes back. And now I box the 0, I have 1 to 7, which is 7, which is a number that I don't know what it is. What's 8 times 8 times 7 times 5?
2,240. So how come the third column is 7 instead of 8? Is it just,
The 0 is used up now.
oh, there's only 1 0.
Well, you have the digits 0 to 9. So if I've used 9 and set it here, and 8 and set it here, and 0 and set it here, this can't be 8, 9, or 0, or else I'd have a repetition. Like I'm pretending I left the 9 here, I'm pretending I left the 8 here, I'm pretending I left the 0 here, then this can be every digit but 8, 9, or 0, or else it would repeat. Yeah.
If you want to like leave the 7 there, can you write 0 to 6 for the next one?
Yes. Like if there was another blank. Yeah. But we're done. Okay. Example 6. Car number plates in an African country consist of a letter other than I or O. How many letters are in the alphabet?
23. 24.
6. I was saying, and you were going 4. 24, 2, 16. Okay. Also, you're usually pretty good with vowels. The vowels are A, E, I, O, U. There's no sometimes Y in math. Okay? What is the opposite of vowel?
Verb.
Consonant. Gold star. A consonant. A verb is an action word. Okay. So, consonant. A consonant is the opposite of vowel, not a constant. A constant is a number without a variable. A consonant is just not a vowel. So if there are A, E, I, O, U, and for vowels, which are 5, there's 21 consonants. There's no sometimes Y in math.
Oh, okay.
Okay.
No Y's.
So here it says, no, there's Y's, but it's just not in a vowel.
Okay, no vowel Y's in
Math.
math.
Yeah. Car number plates in an African country consist of a letter other than I or O. So how many letters do I have for this one? 24. I or O are both out, so I have 24. And I can do it right off the bat because I have to do my restrictions first. And then it says, followed by 3 digits. Boom, boom, boom. The first can't be a 0. We'll deal with that in a second. Followed by any 2 numbers which can't be repeated. Now this is the catch, not repeated. This is not the best worded question because it's not from a diploma. It should say the back 2 numbers can't repeat themselves. So it's not based off the first one at all. Not based off the first one at all. Okay? So, I can do this one, then these 2, but these 2 other ones, like the 2 in the middle, can sit till the very end because they have no restrictions on them. They just need to be digits. Okay? So the second one can't be the digit 0. So it can be 1 to 9, which is how many? 9.
Sorry.
Then we go to the back. This one can be A to Z, which is 26. Then, because it says not repeating, I'm going to hold the A here. Then I have B to Z, which is 25. Then there's no restrictions on these other than they have to be digits. So what options do I have? Yeah, 0 to 9. 0 to 9. It's a large thing.
I'm using in 450,000. Or 4.
Like that?
0. 1404.
All right.
Having trouble saying words.
No, you're good. And then 0, 0, 0?
Yep.
Just want to see what you do. Just want to see what you do.
I'm just like confused. That really
That's real.
Oh, because these are.
An A. Yeah, that's when you get cases, but not right now.
Oh, yes.
Okay. This one here says, James wants to travel from Pitland to St. Luke's. How many different routes are there from Pitland to St. Luke's? So, we know that this is just another way of representing options. So, we know we have to take one option from here and one option from here, and means I multiply, correct? Or, I could take one option from here and one option from here and get me there, correct? Now I'm not going to take the top and the bottom. I'm going to be looping back. It'd be just really weird. I don't know why I'm doing that. So how many options do I have for the first blank between P and Q? 2. And how many between Q and S?
3.
So how many different routes do I have if I go along the top? 6. And honestly, 1, 2, 3, 4, 5, 6. I've had people write something wrong. You can count them. Okay? No knowledge about this, and you could get these. Believe me. Okay? So there's 6 paths I could take along the top. Along the bottom, I have how many here? Options. I have 3 options, but I'm taking one of them. I don't know why I put so slanted. And then this one I have. So how many different options do I have along the bottom?
3.
So how many do I have total? 9. Because I can take these paths,
4.
or, which means I add, These pass, which gets me 9. Roots, pass. There's no other, I don't know. So when it's or, you add. Then we are going to flip over. Okay. We're actually going to go to example 8 here, and then example 9 we're going to use our big brains. Okay? So example 8, the telephone numbers allocated to subscribers in a rural area consist of one of the following. The digits 3, 4, 5, followed by any 3 further digits. Oh my goodness. It doesn't say you can't repeat, so we assume you can. Then the word or, so plus. The digit 2, followed by one of the digits 1 to 5. Followed by any 3 further digits. The other restrictions was this was 3, 4, 5. Somehow skip that. Now some people will say, that's not 7 digits. It doesn't have to be real life.
So isn't it basically only
Yeah. So, and you gave him Colton crap. Yeah. Okay. 3, 4, and 5. How many options do I have? 1, the 3. 1, the 4, 1, 5. What about these? I can do them now because I'm done the restricted ones. 10, 10, 10. I love this one spot on the board. It makes everything look like it's wonky. It's just this. It just started doing this week. It's great. Because I have 0 to 9 here, right? There's no restrictions on these. It doesn't say I can't repeat, so it can be any digits, correct? Make sure you have the dots in between. If you don't have the dots in between, you have the number 1 million. No, you have it even bigger. You have the number 1, 2, 3, 4, 5, 6, 7, 8, 111,101,010. That's the number you have if you don't have dots in between. Because dots means multiplication. Yeah.
Would you ever have to like just add one, like instead of multiplying all of them, would you ever have to just add them?
No, you have to add cases. So like we're adding this case or this case, or happens in the adding of cases. So if you have this, you can have this option or this option. That's where the adding comes, like just in between them, not in between the actual numbers. Yeah. So this one we have the digit 2, one option. The digits 1 to 5. If you get this wrong and you don't use your fingers, you look way more stupid. I would rather you use your fingers. 1, 2, 3, 4, 5. 5 numbers. Okay? There's people who are like, I can't use my fingers because I look stupid. You look more stupid if you use the 4 or 6. There. That actually looks dumb. Dumber is a word. I'm using it. Dumber word. Okay, so then we have 0 to 10.
10.
9.
Yeah.
I don't know what you're talking about. Those are 10.
Even more.
So it's going to be 6,000. Because this is 1,000, that's 5,000. When you add them to 6,000. This one here is where you need your big brains. Not your little, not like you got to dig deep. Ready? Not on the first blank, but on the second one. That means you can't have phones out because that will just ruin your brains. Okay, go team. So we need even 4-digit numbers. 4-digit numbers are? How many blanks?
4.
And the first one can't be a? 0. And the end one has to be a?
Even number.
Even number. Okay. So this can't be a 0. This could be 0, 2, 4, 6, or 8. People will say, I don't know about 0. And then I say, is 10 even or odd? They say even. I'm like, well, I know about 0 and so do you. 0 makes it even. Okay? This one's an easy one. This one doesn't need a big brain. This one you could be on your phone. You shouldn't be. You could be on your phone, you'd be fine. Okay? Because when I can repeat, it doesn't matter what I hold where. Right? Okay. So I have 5 options here. How many do I have for this one? Because I will do my restrictions first. 1 to 9, which is 9. And then here I have 0 to 9. Shockingly, it's the same amount as even, which makes total sense. 4,500. This is where the big brains comes in. And if I wasn't too lazy, I would get Elsa back out again and star this thing. But I'm way too lazy to press that button. So, even numbers. No repeats. Are you paying close attention? Because I will lose you. You're going to be in an uproar if you're not paying attention. You'll all be mad at me in about 2 seconds going, what? You will. So we're not going to get there. We're going to understand. All right. I have the options of 0, 2, 4, 6, or 8. We agree? For my back numbers. Are we all paying attention? Because I literally don't want you will be lost. I get the freak out. I don't want the freak out. Because I want you to understand. I don't like when you get to that point. It makes you stressed out. If I chose, paying attention, if I chose 0 back here, I would box 0. We agree? Would it affect the front blank? No, because I have 1 to 9. We agree? Okay. But if I chose the number 2, 4, 6, or 8, would it affect the front blank? Yes. So I have to do 2 cases. I have to do a case where it ends in 0, because it wouldn't affect the front blank. And then I have to do a case where it ends in 2, 4, 6, or 8, because it would affect the front blank. Does that make sense? Okay. Now you won't find it hard. Okay. Because that's the hardest part to understand. So I can end in a 0, it won't affect my front. So I can only put the cases that would actually do the same thing together, correct? 2, 4, 6, or 8 would do the same thing. It's going to take 1 off the front blank. But 0 won't. So I have to do a case where it ends in a 0, or a case where it ends in 2, 4, 6, or 8. Does that make sense? And we didn't have to do this with odds. Why didn't we have to do this with odds? Because when it was odds, it was 1, 5, 7, or 9. That affected the front blank. All of them did. Right? It's just because of this silly 0 that it doesn't affect my front blank, because my blank can't be 0. Make sense? Okay, let's look at the 0 one first. So I pick 0, 1, and then I box it. And from now on, I can never use 0 again. Correct? Because there's no repetition. So what do I have for the front blank then? 1 to 9, which is how many options? No. 9.
Sorry.
So I boxed the 9, and now I've used up 0 and 9. So what do I have left for here? 1 to 8. I'm telling you, if you box these numbers, it will make your life easier. Okay? 1 to 8 is how many options? 8. Then I hold, let's say, the 8. Then I have 1 to 7. Now the hardest part for some people is to understand which numbers I'm holding. That is the hardest part because it doesn't matter which one you hold. I'm holding the 8 on this one. I could have held the 1 and then did 2 to 8. It would still give me the same amount of options. I just usually pick the last one because it's easier to count the number of options if I have 1 to that number. It's just that number. Okay? It doesn't matter. You can box it and then that would be your pretend number that you would have gotten out of it. It doesn't matter just because there's no more blanks. And that number doesn't affect my other one.
Right.
So when I go to a brand new case, I get all my numbers back. So these numbers affect each other, but then when I go to OR and I get a whole new case, I'm back with everything again. I have them all back. Okay? So how many options do I have for this blank? 4. Now I hold the 8. Let's say. Now I have 1 to 7 and 9, which is how many options? 8. Do you see how these aren't the same amount of options, right? That's why I couldn't put them in the same case. Now what's the catch on this one? We have 1 to 7. But it's not 7 options. Yeah. You have to bring the 0 back. Because you couldn't use the 0 back here, I didn't give it as an option. You didn't use the 0 here. So it's in your best interest to do this. Okay, I used up an 8. I used up a 9. I now have 1 to 7 and 0. It's often easier if you go, hey, okay, 8's out, 9's out, what's still left? 1 to 7 and 0. If you do that, that's why the boxing has made life easier. You'll do better. So this is 8. I'll hold the 0 because I'm lazy. And it's 1 to 7. Pretend I'll hold the 7. So this is 7. When I type that in, I don't know. Yeah. 2296. I don't even know what's going on. Okay. It's 2296. Okay. Paying attention? Once again, I'm teaching you something that will matter. I'm just move ahead so you can see. Okay, when you're given the word English, or you're given a word, this is when I need you to tell you to go home again. Same thing with the last one. If you understand this, these are really easy. If you don't understand, it's really hard. Pretend that when you're given the word English, you're given Scrabble tiles. Okay? You're handed the word English on Scrabble tiles. Do you understand that? So, here's the Scrabble tiles in my hand. This is the word English. They handed it to me, threw it in my hand, and now I can do this, but whatever. I still have all the letters for English in my hand, right? So, how many E's do I have? One. People will think I have an unlimited amount. No, I have Scrabble. I threw all Scrabble tiles in my hand. I got rid of the E. Now, how many N's do I have? One, took it, tossed it down. G's, L's, I's, S, H. So guess what? English is never repeating. You are always going to box when you give the options of the word English, when they give you English and you go to write the letters below, like the options, just like 1 to 7 or whatever, they are not going to say you can't repeat, but it is assumed that you cannot repeat. You have English Scrabble tiles in your hand. Once you've given away an E, you don't have another one left, do you? Like I only have not an unlimited amount, correct? So if you think about it as Scrabble tiles, and you think about it as always not repeating, well, you could repeat. You could have the word peel. I'd have a P, an E, an E, and an L, correct? So I'd have 2 E's, that's it. But I would still box 1 E once I used it, and now I just have another E I could lay somewhere, correct? But I'd still only have 2 E's if I had the word peel. Does that make sense? So they're not going to say you can't repeat, but you can't repeat. You have the word English and Scrabble tiles in your hand. Does that make sense? All right. So here it says, consider the number of distinguishable 4-letter arrangements. So how many blanks am I going to have? How many blanks am I going to have? I'm going to have 4. That can be formed from the word English. When given a word, it is assumed you have only letters contained in that word amount of the times they occur in that word. So you got Scrabble tiles. If you always think of it as Scrabble tiles, you'll be golden. Okay? So here it says, any letter can be in any position. Still 4 letters only though, right? We're making 4-letter words. Any letter can be in any position. There's no restrictions on this. I can start anywhere. So this is a little excessive, but I'm going to do it anyways. I have E, N, G, L, I, S, H here. How many letters? 7. What am I going to do every single time I have a word though? Box 1, right? Because I'm pretending I'm like tossing that Scrabble tile out. Correct? I'm going to place an E in this blank. Now I have N, G, L, I, S, H. So how many do I have? 6. Then I box 1. Then I'm going to have 5. Then I'm going to have 4. Do you always have to show all the options below once you get a pattern going there? No. What's 7 times 6 times 5 times 4? Then B says the first letter must be E. I'm telling you, if you treat these like Scrabble tiles, these are really easy questions. The first letter has to be an E. E. How many options? 1. I boxed it. How many letters do I have left? 6. Say I keep the G here. Then how many would I have left? Say I keep the L. Then I would have 4. This is not Scrabble. The words don't have to be real. It could be like evil gold. Okay? We don't care. 120. The first and last letters must be vowels. How many vowels are in English? E and
2.
I. So I can start at the first or the last, doesn't matter. I'm going to go here. I have E and I, which is how many? What do I always do when it's this word? Box 1. So I'll pretend I box the E. You can box the I. It doesn't really matter. Just the other one will get written here. So I have an I here, which is one option. How many letters have I laid down? Out of? So how many do I have left? 5. Then 4. So this is 40. And then the last one is a little bit of trickery. The word must contain G. It doesn't say where. So, no, it has to contain G though. So I could have a G here, or a G here, or a G here, or a G at the last blank, correct? Before you go like blank happy, we'll do one and then you'll see the difference. So G is how many options? 1, I laid a word here, or a letter here. How many do I have left? 6, then 5, then 4. What's going to happen here? I'm going to get all this stuff back to new case. So then for this one, I would have 1, then 6, 5, 4. Same number. 1, 6, 5, 4. 1, 6, 5, 4. So instead of showing the 4 cases, I could go, hey, it's just going to be 4 cases. Each case is going to be 120. So I could just go 120 times 4. Or you could add them all up. It doesn't really matter. Does that make sense? After this is the questions to work on in your booklet. I don't even do the textbook. It's scary. So there's questions to work on, and then following that are the answers. So there's like a page, there's a full page, and then there's a top part of the page, and then right after that's answers. Do you see it?
Yeah, 12, 71.
Yeah. So I'm marking these ones down in your homework for next week. What do we do next Friday? Yeah. The problem with perms and congs is you need to practice a lot of questions because they're all a little different. So you just need to practice them to get better at them.